Okay, so up to now, we've done some fairly pretty basic ones. Even the quadratics we did, we were able to solve by using the square root method. So what we're going to look at now is not so much intensifying the trigonometry, but we're going to intensify the algebra part of it. All right, so what I'm going to do is I'm going to solve an equation, 10 sine squared theta plus sine theta minus 3 equals 0, and I want the answer between 0 and 2 pi. Once again, I need my answers. I need you to express your answers in terms of radians. So, I can't use a square method on this, so I'm going to look to see if there's factors through the AC method of factoring. So I'm going to do 10 times negative 3, which is negative 30. And is there any factors of negative 30 that'll add up to being 1? And in fact, that is a positive 6 and a negative 5. So I'm going to take that and split this middle term. 10 sine squared theta minus 5 sine theta plus 6 sine theta minus 3 equals 0. We're going to group like we always do with AC. We're going to take out a GCF. In this one, it's going to be 5 sine theta. 5 sine theta, and that leaves me back with 2 sine theta minus 1. And then here I've got a 3, which is the greatest common factor. So we'll take a 3 out, and that leaves me with 2 sine theta minus 1 equals 0. So then this finished factors to 5 sine theta plus 3 times 2 sine theta minus 1. This equals 0. Now we're going to do my zero product property just like when we're solving quadratics. We're going to set each factor equal to 0. We're going to do 5 sine theta plus 3 equals 0 and 2 sine theta minus 1 equals 0. And we're going to solve each of these. We're going to get sine of theta equals a negative 3/5, and we get sine of theta equals 1/2. Okay. So this one right here, I should be able to use the unit circle real fast with the left-hand trick and find my answers. These answers are going to be pi over 6, and sine is also positive in quadrant 2, so it'll be 5 pi over 6. So those are solved, boom, done. You know in the unit circle, don't have to really mess with any of that. This is not on the unit circle, so we have to use our reference angles. So I'm going to get theta by itself, and I'm going to do arc sine of negative 3/5. Need to throw that into a calculator. When I throw that into the calculator, I'm going to get that it's approximately negative 0.644. To find my reference angle, I need to do the absolute value of this. So my reference angle is going to equal 0.644. This is what I'm using. Now I know it's an approximate of theta, but this is my reference angle. Now I'm going to come back here and say, all right, well, what two quadrants is sine negative in? Well, you can do the all students take calculus. It's going to be in quadrant 3 and quadrant 4. Let me give myself a little bit more space to write here. Quadrant 3 and quadrant 4. So I'm going to, let's see, my formula for quadrant 3 was pi minus my reference angle, which is 0.644. When I throw that, plus, what am I thinking? It's quadrant 3. When I throw that into the calculator, I get 3.786. And in quadrant 4, it is 2 pi minus my reference angle at 0.644. When I throw that into the calculator, I'm getting 6.927. Therefore, my answer to theta is approximately, and I'm going to put approximate because even though these are exact, these are approximates. 3.786, 6.927, pi over 6, and 5 pi over 6. And voila, I'm done. And there's a solution to that. Didn't really intensify the trigonometry. What I did is we're intensifying the algebra, having to factor it, use a zero product property, and then from there do our reference angles. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click
the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.